Hello everyone. Today in this session we will discuss about the design reuse in gaming architecture and programming subject. First of all, we will move toward the what is meant by the design reuse. So generally the design reuse, it is done through the design pattern, and it is one of the solution for the problem that frequently come up in the software development. So the design pattern, they are arise out of the experience of the designer, and they are easily understood and applied to the various project by the developer. So these are specific to the domain, so that the developer are understanding the domain well before they start the coding. Some common design that will act as a design pattern and they are applicable to the games is as follows. So the first one is object factory. So first one design pattern is the object factory. So we will see what is the main functionality of this pattern or how it can work. So object factory is generally used to create, or we can say that the object factory create the family of object. So all the object which is created by the factory, they are derived from the same abstract class, and they are they are returned as a reference to this class. Again, the object factory, they are keeping the track of all the object in the list. So whenever the particular object it is deleted or it is removed from the list, so the object factory receives the request from the client to create an object representing a token within a level. So each token in this object factory, it have an unique ID, and they are and loading is passing that ID to the object factory and then getting a return pointer to the base class. So at the end of each level, if object remain in the list, they are automatically deleted, and this is done using the memory tracker class, which is an instantiated members of the game object class. So in this, the constructor of this class, it stored the reference to the game object, and they are insert itself to the list in the factory class. So whenever the particular game object it is being deleted, the destructor members of the memory tracker it is being invoked, and they are removing the reference to it itself from the factory class list. So this is about the object factory. So from this we can understand it consists of a family of object. All the object is created by the factories, and they are derived from the same abstract classes. Again, the functionality of the object factory is to keeping the track of all the objects. So whenever the particular object it is being deleted, so in that case the object factory will maintain all things, so it can share or it can create one unique ID, and through this all the object in the object factory they can work. So this is all about the object factory. Second one thing, or second one pattern we have to see is the singleton pattern. So singleton, this pattern ensures that singleton word, it specify that a single thing. So we can say that a one instance of a particular object can exist in the application. So in this pattern, it ensures that only one instance we can use for a particular object, and that can be exist in an application. So for example, we can consider only one instance of an object wrapping the sound card or the graphic card it is required. So the singleton pattern, it consists of various singleton objects. So this singleton object, they are then instantiate mostly on the program initialization, or they are first use of the object. So in the first case, the constructor of the singleton is the first called before the main function, and in the second case it is called on demand. So singleton, it is not instantiate if not called. So the static modifier, it always take care that only one instance of the singleton class exists, and an example would be for a class that read and write a configuration file. So this is a best example or the simple example for the singleton pattern. So this is the second one pattern. Third one pattern is the Plywood pattern. So this pattern is generally used along with the singleton pattern. So the Plywood pattern generally allows the multiple instance of the class to be instantiated, but all of them refer to common component shared by them all. So the individual configuration data, it is just stored within the Plywood object. So the advantages of the Plywood pattern is it saves the memory, and there is some also disadvantages with the Plywood pattern is that it can be used only for read only the resources, and if it is no use if local modification to the global resources has to be made. So this is about the Plywood pattern. So from the singleton we can understand it is related with the single instance, and the Plywood pattern it is related with the multiple instance. Fourth one is the chain of responsibility pattern. So this pattern, from the name of this pattern we can understand it consists of a chain of objects. So this chain of objects, they can receive the notification of an event, and through this they can avoid the direct coupling of the event. Again, the signaling the object with the chain of object interested in handling that particular event. So in this, the implementation, it can be done through the class diagram or the runtime object hierarchy. But there is some disadvantage in this also. So the disadvantage of the class hierarchy is that the chain, it is fixed at the compile time, meaning we can see that from this the class hierarchy it cannot be changed because it is fixed, it is in the format of chain, right? So this is the fourth one. Fifth one is the iterator and reverse iterator pattern. Again, iterator and reverse iterator pattern. So in this pattern, the game developer, they are generally simplifying the algorithm, and they need to iterate on the list of items, and through this it can increase the speed of game execution. So in the game development, we could create an iterator that will iterate through a list of game object and then return them in the ascending order of the distance from the camera. So the code will contain the class declaration for the list with the insert and get members to insert and retrieve the members. So in this, the abstract class iterator, it is to be defined outside the list classes and declaration, and again it defines the interface for an iterator and allows the iterator for an collection classes. So this is about the iterator and reverse iterator pattern. And the last one pattern we have to discuss today, that is the template and strategy method pattern. So again, template and strategy method pattern, it having the different functionality. So generally this pattern allows the dynamic selection of the algorithm. So we can consider one example for this. The computer control character, they can use the different strategy methods for choosing the different style of play. So in this, the coder, they can implement a generic style and they are attaching a new strategy at the runtime to customize the style. Later on, the different type of style you can add if required to the generic class, and you can encapsulate it with the new algorithm in the concrete class for that style of the play. So adding many style can create a problem in managing and maintaining of the code. So this is all about the template and strategy method pattern. So this is the sixth pattern that we have discussed in this session. So thank you all of you for watching this.